Okay, let's do problem 146 LRU cache. So in this question, we have to design a data structure LRU cache, as well as these get input methods. So let's have a look at the example. So we initialize with a capacity of 2, and then we put key of 1 and value of 1. So now cache is 1, 1. And then we put another key of 2 and value of 2. Now our cache is 1 and 1 and 2 and 2. At this point, 1 and 1 is list recently used because we added this 2 and 2 most recently. And then we get 1, so we get the value of the node which has the key of 1. So that means it's most recently used. That makes this list recently used. So when we put 3 and 3, because our capacity has reached the maximum capacity, so remove the LRU, which is this. So we put 3, 3 here, and then when we get to there isn't anything that has the key of 2 because we removed it. So we repeat this process over and over again. So to solve this question, we have to use doubly linked list, and the whole idea is I might as well draw it properly. So the whole idea is whatever that's on the furthest right hand side of the list is the LRU. So when we add something or when we use something, we have to move that to the head. So because this is essentially head, this is tail, and then they will be constantly used and updated, it would be ideal to have this dummy head here and then dummy tail here. So it would have like this. And every time we put the key and value into the list, it will come to here, just between dummy and the head. And if when we put the value, we are also going to create a hash map. This will be int, this will be node. So we can keep track of what's in the hash map. Or not what's in the hash map, what's in the list. So we'll see how they're going to be used as we write down the code. But before we do anything, we have to create a private static class of node. So unlike other node, it will have int key and then int val, and then node previous and then node next. And we do need constructor int key and int k and int v. It will be key is equal to k and val is equal to v. Now we do need to create hash map. So private map of integer node. Let's call it map, new hash map. And we do need to create dummy head and dummy tail. So node dummy head is equal to new node of 0, 0, and node dummy tail is also equal to new node of 0, 0. And then there should be capacity. Okay, let's just write them private here. Capacity, and this that capacity will be capacity, and our initial setup will be we don't have any of them. We just want dummy head to point to dummy tail, and then dummy tail to point to dummy head, so that when we add one node, we can rearrange it so that it points to each other like this. I'm just gonna say that's dummy tail, dummy head. So dummy head dot next is equal to dummy tail, and dummy tail dot previous is equal to dummy head. All right, so let's implement the logic for put, because after we put it, we do know what to do with the get. So first of all, we are gonna check. So when we put the key and value, we have to check if it already exists in hash map. So node is equal to map.get key. And then if node is not equal to null, we have to do something else. We have to do something, but we can actually, else may not be necessary because you can just return. At the end of this, we can just return here. So what are we going to do if the node already exists? Suppose what we are trying to get, we said the, I'm just going to put random value here. So this one has key of 1 and then value of 5. So key will be 1, and then we have node that has key of 1 and value of 5 here. So we are trying to put the value. So that means we are trying to update our value. So node.val is equal to value. So say this is 6. That means we have to update this to 6. That's what we did. So we updated it 6 and 6. Perfectly fine. Then what's our next step? We need to move this to the front. How do we move it? We have to take this one out and then re-establish this link and then this link. So what is this? It is node.previous, and then that's node.next. I think it would be much cleaner if we take out the method. So private void, we can say move to front, because what we are trying to do is we're gonna take this one out and then move to the front, which is where the head is. So how do we do it? We do node.previous.next is equal to node.next. So that will be node.previous, and this one's next is equal to node.next, and then we have to do the node.next.previous is equal to node.previous. Amazing. And now we have to put this into here, which means we need to make this to point like this. So that will be dummy node.next is equal to dummy head.next. So that will be this. That will be this. And then let's do this one. So node dummy head.next.previous is equal to node. Now let's do this. Oh, right, actually let's do this. Dummy head.next is equal to node, and then we can do this. Node.previous is equal to dummy head. Amazing. So we can do move to front node. And then we can just finish it. But if the node was null, which means there wasn't any, we need to create a new node. So node new node is equal to new node of key and value. And we have to put that into the hash map. So that would be map.put key and new node. All right, so that means we can forget about this. We created a new node, so the node we're trying to put in here doesn't exist. So we create a node, and we have to move this one to here. But we've already written the logic for this, but we don't really need the logic for this because that's detaching from the tail. This is detaching from the tail. That's adding to head. So we do need the logic for adding to head. So let's take this one out. And can just do add to head node, and we can also have add to head node, new node. Right, so we've added the new node. We have added this one to here, but we also need to check if the capacity has reached or not. So if map.size is greater than capacity, that means we have to remove the one at the end, the list recently used cache. So first of all, we can remove from the map. Remove. We have to remove the last one. This is the last one. So what's the key of this? It will be dummy tail dot previous dot key. So we removed it, and then so this should be out of the picture, and we now have to reestablish this. But at the moment, this is node. Actually, we don't have any node at the moment. We only need to know this and this and establish connection. To do that, we can do dummy tail dot have we used dummy head? Okay, dummy tail dot previous dot next is equal to dummy tail. Dummy tails previous dot previous next is equal to dummy tail, and then dummy tail dot previous is equal to dummy tail dot previous dot previous. So dummy tails dot previous should be dummy tails dot previous dot previous. All right, so that's it for our put method. Let's implement our get method. So get, we need to get the node from the map, and if node is equal to null, we return -1, they said. And then after getting it, which means if the node wasn't null, say it was like somewhere here, we have to take it out and then move to the front. But that logic already exists, which is move to front. Move to front, node, and then we have to return the value of the node. Node. Okay, let's run the test. All right, let's submit. Okay, that's it.